Hello there, and welcome to Deep Earth Stories. Get comfortable. Turn the lights down if you can. Because what we are about to explore together has been waiting a very, very long time for someone to listen. But before that, tell me in comments where are you listening from and what time is there right now. And please subscribe to my channel. Tonight we are going to travel somewhere very far away. Not across an ocean, not across a continent. We are going to travel back in time. A very, very long way back. So far back that the world you know, the green hills, the blue sky, the familiar white moon hanging quietly above the clouds, none of that existed yet. Tonight, we're going to talk about a time when Earth had two moons. Maybe you're already lying down. Maybe the room is dark or nearly dark. Maybe there is a soft glow from a lamp somewhere, or just the quiet darkness behind your closed eyes. Wherever you are right now, I want you to take one slow breath in. Hold it for just a moment. And then let it go. There is nothing you need to do tonight. There is nowhere you need to be. This story will come to you slowly, like water moving over smooth stones. You do not need to remember every word. You do not need to stay fully awake. If your thoughts begin to drift, that is perfectly fine. That is exactly what this is for. So settle in. Let your shoulders drop. Let your hands go soft. We have a long, gentle journey ahead of us, and it begins a very, very long time ago. Chapter 1. The sky that no longer exists. Imagine for a moment that you're standing outside on a clear night. The air is cool. There are no city lights anywhere. There are no buildings, no roads, no sound of cars or planes or distant music. There is only the earth beneath your feet, the stars above your head, and the wide, dark, breathing sky. Now look up. You see the moon, that familiar shape, that soft white circle glowing gently above the horizon. You've seen it 1,000 times. Maybe you watched it as a child through a bedroom window. Maybe you've seen it reflected in still water. Maybe you have watched it rise slowly over a rooftop on a warm summer evening. It feels permanent, doesn't it? The moon feels like something that has always been there and always will be. It feels like one of the few things in this world that never changes. But what if I told you that the sky was not always like this? What if I told you that there was a time, long before any human being ever looked up, when the night sky held not one moon, but two moons, hanging side by side in the ancient darkness, one large and bright, just like the one we know today, and one smaller, quieter, dimmer, a second companion following the same slow path across the sky. For a moment, just breathe. Let that image settle in your mind. Two moons. The Earth was younger then. Everything was younger. The continents looked nothing like they do now. The oceans were in different places. The very air was different. And above it all, two moons moved slowly through the night. This is not a fairy tale. This is not science fiction. This is a real scientific idea, supported by real evidence, explored by real astronomers and geologists who have spent their lives asking one quiet, enormous question. How did our moon get there? And when they started to answer that question, something unexpected emerged from the data. Something that made even experienced scientists pause and look up at the night sky a little differently. The evidence began to suggest that once, long ago, there were two. Let us begin there. Let us begin at the very beginning of this story. And if your eyes feel a little heavy already, that is perfectly fine. Just keep listening. The story will carry you. Chapter 2. How the Moon Was Born. To understand the idea of two moons, we first need to understand how the moon we know came to be. And that story is already one of the most dramatic stories in the entire history of our solar system. Picture a time about 4.5 billion years ago. The solar system was very young. The sun had just begun to burn. All around it, Enormous clouds of dust and gas and rock were slowly pulling together, clumping, colliding, forming the early planets. Earth was one of those planets, but it was nothing like the Earth we know. It was not blue and green and gentle. It was a violent, burning world. The surface was covered in liquid rock. Volcanoes erupted constantly. The sky was thick with ash and heat. There were no oceans yet, no continents, no life of any kind, just heat and rock, and the constant slow violence of a young world building itself. Now imagine another world, about the same size as Mars, roughly half the size of Earth. This world also formed early in the solar system's history. Scientists have given it a name. They call it Theia. Theia moved through the inner solar system in a path that, over millions of years, grew less stable. Slowly, very slowly, its orbit began to drift. Its path began to cross closer and closer to the orbit of the young Earth. And then, one day, if we can even call it day, because the sun back then looked very different and time itself felt different, the two worlds met, not gently. The impact was enormous, almost beyond imagination. Theia struck the young Earth at an angle, not head-on but at a glant. It hit with a force so unthinkably large that both worlds were partially destroyed. The outer layers of Earth were torn away. Theia itself was shattered. Rock and gas and molten material sprayed out into the space around Earth in a vast glowing ring. For a moment, just breathe. Imagine standing in space and watching this happen from very far away. You would see a bright burst of light, then a slow, spreading ring of glowing debris circling the young Earth. Gradually, over millions of years, that debris would cool. It would clump together. It would gather into a new shape, and that shape slowly, quietly, over unimaginable time, would become our moon. This theory, that the moon was born from a collision, is called the giant impact hypothesis. It is the most widely accepted explanation for how the moon formed. Most planetary scientists today believe some version of this story, but here is where things get interesting. Here is where the story of the second moon begins. For many years after the giant impact hypothesis was proposed, scientists noticed something strange about the moon. Something that didn't quite fit. The moon is not the same on both sides. You may have heard the phrase, the dark side of the moon. It is actually called the far side, the side that always faces away from Earth. Because the moon rotates at a speed that keeps the same face pointed toward us at all times, we never see the far side from Earth. Not with our own eyes. For thousands of years, humans had no idea what the far side looked like, and when we finally saw it, first with spacecraft in the 1950s and 1960s, and then in much greater detail over the following decades, what we found was surprising. The two sides of the moon are very different. The near side, the side we see, has large flat plains of dark rock called Maria. Maria is the Latin word for seas because early astronomers thought they were actual oceans. They are not, of course. They are ancient lava flows, broad and smooth and dark. But the far side of the moon has almost none of these flat plains. Instead, it is covered in mountains and craters, rough and uneven, much thicker in its outer crust. Why would one side of the moon be so different from the other? For a long time, this was one of the quiet mysteries of planetary science. Scientists had various ideas. Maybe the near side was heated more by Earth's gravity and stayed molten longer, allowing lava to spread out flat. Maybe there was some other force at work. And then, in 2011, two scientists named Martin Jutzi and Eric Asfau published a study that proposed something extraordinary. What if, they asked, the moon had a companion? What if, after the giant impact, not one moon formed, but two? Chapter 3. The second moon. Let us slow down here. Let us take this gently. The idea goes like this. When Theia hit the young Earth and sent a spray of debris into orbit, it is possible, perhaps even likely some scientists now argue, that the debris did not all gather into one single moon. Instead, the debris may have formed two separate clumps, one large clump which became our moon as we know it today, and one smaller clump, maybe about 1/3 the size of our moon, which formed a second, smaller moon in the same orbital neighbourhood. This second moon would not have been tiny. We're talking about something perhaps 1,000 kilometres across, roughly the size of a large asteroid or a medium-sized dwarf planet, not a little chip of rock drifting through space, a real round world, a companion to our moon. And for a while, perhaps for tens of millions of years, both moons circled the Earth together. Can you imagine the night sky then? Of course, there were no eyes to look up at it. No living thing existed yet that could see or understand what hung above. But if you could go back and stand on the surface of the young Earth, protected somehow from the heat and the toxic air, and look up at the night sky, you would see something never seen by any human being in all of history. Two moons, one large, one smaller, moving slowly against the stars. For a moment, just breathe. It is a peaceful image, in a strange way. Two worlds, side by side, pulled gently by Earth's gravity, each one lighting the ancient darkness in its own quiet way. Maybe that smaller moon cast a faint, softer glow across the hot, barren landscape. Maybe its light mixed with the light of the larger moon, creating strange double shadows on the volcanic rock. Maybe the tides of the young oceans, those first primitive oceans forming slowly on the cooling Earth, moved in complex double patterns, responding to the pull of two separate moons. We can only imagine. But this is not just imagination. The science behind the idea is real and careful and thoughtful. The two-moon hypothesis was proposed to explain real data. And as we move through this story, we will look at that data together. We will follow the clues. We will see where the science leads. And along the way, if your breathing has grown slower, if your thoughts have begun to soften at the edges, that is perfectly fine. Just keep listening. The story is just beginning. Chapter 4, A World Still Becoming. Before we go further with the two-moon story, I want to take a moment to paint a picture of the Earth during this time. Because to truly feel this story, you need to understand how different the world was 4.5 billion years ago. The number is almost impossible to hold in your mind. Humans have only existed for about 300,000 years. Recorded history goes back only about 5,000 years. So when we say 4.5 billion years, we're talking about a stretch of time so vast that all of human history would be a single heartbeat within it. The Earth in those ancient days was called the Hadean Aeon. Scientists named it after Hades, the Greek underworld, because the world at that time truly resembled what ancient people imagined the underworld to be. Dark, hot, volcanic, hostile to anything we would recognize as life. The surface of the Earth was largely molten. Huge seas of liquid rock, called magma oceans, covered much of the planet. Volcanoes erupted constantly, not occasionally like they do today, but endlessly, all across the surface. The sky above was thick and dark, filled with carbon dioxide, water vapour, nitrogen, and various gases that would be toxic to any modern living thing. There were no blue skies back then. The sky, if you could call it that, was more likely a dense, heavy atmosphere of swirling dark clouds, lit from below by the glow of the molten surface. And yet, there was water. Not on the surface yet, not in any stable way. But water existed, locked inside the rocks that form the planet. And slowly, very slowly, over millions of years, as the surface began to cool, some of that water began to escape. It rose into the atmosphere as steam. It fell back down as rain. The first rains on Earth were extraordinary. They fell on a surface still hot enough to turn water instantly back into steam. But as the surface cooled, just a little, then a little more, the rain began to stay. Puddles formed, then pools, then gradually something like oceans. These early oceans were not blue and calm and beautiful. They were probably warm, perhaps even hot. Their chemistry was nothing like today's ocean. But they were there, and the presence of liquid water is one of the most important events in the history of any planet. Because where there is liquid water, strange things can happen, but we are getting ahead of ourselves. At the time we're talking about, in the very early days after the giant impact, in the time when the second moon may have still been in the sky, there was no life yet, not a single bacterium, not a single molecule that could truly be called alive. Just the Earth slowly cooling, the oceans slowly growing, the moon above, or perhaps two moons, slowly pulling the tides. For a moment, just breathe. Think about how much time passed with nothing watching, nothing aware. The sun rose and set over a planet with no one to see it. Stars turned in the night sky with no one to name them. Seasons did not yet exist as we know them. The very rhythm of the Earth's rotation was different. In those early days, the Earth spun much faster than it does now. A day on the early Earth was only about 5 or 6 hours long. Think about that. The sun would rise, move quickly across the sky, and set again, all within 5 or 6 hours. And then the moons would rise in the darkness, two pale shapes moving against the ancient stars, moving faster across the sky than our moon moves today, because the Earth was spinning so quickly beneath them. Gradually, over billions of years, the gravitational pull of the moon, or the moons, slowed the Earth's rotation down. Day by day, century by century, the spinning slowed. The days grew longer, very slowly, almost imperceptibly, a tiny fraction of a second per century. But over billions of years, those fractions added up. Today, a day is 24 hours. But it was not always this way. The Earth has been changed by its moons, shaped by them, slowed by them, and perhaps the story of how we got from 2 moons to 1 shaped this planet in ways we are only beginning to understand. Chapter 5. The slow collision. Now, here is the part of the story that is both beautiful and a little heartbreaking, if you let yourself feel it that way. Remember the second moon? That smaller companion circling the Earth alongside our large familiar moon. It did not stay forever. Nothing in the solar system stays exactly as it is. Everything moves. Everything drifts. Orbits shift over long periods of time. Gravity pulls and pushes in ways that are subtle but relentless. Over tens of millions of years, the orbit of the second moon slowly changed. Scientists who have modelled this suggest that the 2 moons would have been in what is called a co-orbital configuration, meaning they shared a similar orbit around the Earth, moving in the same direction, separated by a careful gravitational balance. But that balance was fragile. Slowly, the smaller moon drifted closer to the larger one, and eventually, after perhaps 50 million years of the 2 moons circling together, they met. Not in the same violent, explosive way that Theia met the Earth. This collision was different. The scientists who proposed the 2-moon hypothesis, Jutzi and Asfaug, describe it as a slow impact. The second moon did not crash into the larger moon at high speed. Instead, it approached slowly, and then gently by cosmic standards it merged. The smaller moon did not punch a hole in the larger one. It didn't create a great crater. Instead, it essentially spread itself across the back of the larger moon, piling up thick layers of material on one side. The far side. The side that always faces away from Earth. That is the hypothesis. That the thick crust of the far side of the moon, those extra mountains and highlands that puzzled scientists for so long, is the remains of the second moon. flattened, merged, absorbed into the surface of the moon we know today. If this is true, then in a way the second moon is still with us, not as a separate world, not as a distinct shape in the sky, but as part of the moon's own body, hidden away on the side we never see from Earth. For a moment, just breathe. There is something quietly beautiful about that idea. The second moon is not gone. It is just changed. It became part of something else. It gave its material, its substance, its ancient rocky body to the formation of the moon we have come to love and rely on. Things do not simply disappear. They transform. They become part of other things. The atoms that once made up that second moon are still out there. Some are in the lunar highlands of the far side. Some were scattered across space and fell onto the young Earth, mixing into the rock and soil. Some became part of the water on our planet. Some, in a chain of changes so long and so slow that no human mind can truly follow it, eventually became part of the ground we walk on. Everything comes from somewhere. Everything goes somewhere else. The second moon did not die. It rested. Chapter 6. What the rocks remember. One of the quiet wonders of science is that rocks remember things, not the way you and I remember things, not with feelings or stories or faces, but in their chemistry, in their layers, in the tiny traces of ancient energy still locked inside them. Rocks carry information about what happened billions of years ago. When scientists study the moon, through lunar rocks brought back by the Apollo missions, through data from orbiting spacecraft, through the careful mathematics of orbital mechanics, they find clues. The moon rocks brought back from the near side and the far side are chemically different in ways that are consistent with the two-moon hypothesis. The far side's crust is thicker. It contains more of certain minerals that would be expected if a large body of rock had been added to its surface from outside. Of course, this is not definitive proof. Science rarely works in certainties. Instead, it works in probabilities, in evidence, in models that either fit the data or do not. The two-moon hypothesis fits the data. It is not the only possible explanation, and scientists continue to debate it. But it is a serious, well-supported scientific idea, published in respected journals, taken seriously by respected scientists. And there is something wonderful about that. Something wonderful about the fact that buried in the data, in the measurements of lunar rock density, in the careful orbital calculations, in the strange asymmetry of the moon's two sides, there is a story of two worlds that once circled the Earth together, a story that no human being was alive to see, but which the rocks remember. Imagine a geologist sitting at a desk surrounded by samples of lunar rock, comparing numbers on a screen, working quietly, carefully, for years, and slowly coming to realize that those numbers are telling a story, that those rocks are describing a sky that no living thing ever saw. There's a kind of beauty in that, a kind of deep, quiet beauty. Scientists are, in their own way, listeners. They listen to the rocks, they listen to the math, they listen to the data, and sometimes, if they are very patient, the universe speaks back. For a moment, just breathe. Notice how quiet everything is right now. Notice the slow, gentle pace of your own breathing. Notice how the world outside, whatever world surrounds you tonight, is going about its slow, quiet business while you rest. We are small creatures in a very large universe. Our lives are brief flickers of awareness in a story that began billions of years before us and will continue billions of years after. And yet, here we are, curious, wondering, listening to stories about two moons and ancient collisions and rocks that remember things from the beginning of the world. That is something. that is not nothing. If your eyes are heavy now, let them close. The story will still be here. You can drift and return like a tide that knows its way home. Chapter 7. The moon we have now. Let us rest for a moment on the moon we know, the moon that hangs above us tonight, the one that has guided sailors and farmers and dreamers for all of human history. Our moon is, by cosmic standards, unusually large for a moon of its planet. Most moons in the solar system are tiny compared to the worlds they orbit. Our moon is about 1/4 the size of Earth. That is remarkably large, and that size has had enormous effects on our world. The moon stabilizes the tilt of the Earth. Without the moon's gravitational influence, the axis of the Earth, the invisible line running from the North Pole to the South Pole, around which the Earth spins, would wobble chaotically over thousands of years. It could tilt far to one side or far to the other, causing the seasons to become extreme, even catastrophic. With the moon there, the Earth's tilt stays relatively stable. The seasons change, yes, but they are predictable and moderate enough for life to adapt. The moon also creates tides, and those tides may have played a role in the beginning of life on Earth. Scientists believe that the tidal zones, those areas of coastline that are sometimes underwater and sometimes exposed to air, may have been ideal environments for the chemistry that eventually led to the first living things. Places where molecules could concentrate in rock pools, mix in new ways, and experiment slowly across millions of years with the chemistry of life. If that is true, then the moon did not only shape the Earth's seasons, the moon may have helped life begin. And if there were once two moons, both pulling at the tides, creating more complex, more varied tidal patterns along those ancient shores, we cannot know for certain what effect that would have had. Perhaps the more complex tides would have been even more beneficial for early chemistry. Perhaps they would have made things harder. Perhaps they would have been neither good nor bad, just different. But it is a quiet, fascinating question. What would our world be like if the second moon had never merged? If two moons still hung in the sky tonight and the tides were different, and the nights were differently lit, would life still have begun? Would it have found a different path? Would there be creatures on this Earth that look up at two moons and take both of them completely for granted? We cannot know, but we can wonder. And wondering, done slowly and gently in the dark, is its own kind of rest. Chapter 8. The age of wondering human beings have looked up at the moon for as long as there have been human beings. Long before anyone understood what the moon actually was, before anyone knew it was a rocky world, before anyone understood orbits or gravity or the giant impact hypothesis, people looked up and wondered. The moon appears in the oldest stories we have, in cave paintings from tens of thousands of years ago. Marks that may represent the phases of the moon are scratched into stone. Ancient cultures all over the world developed lunar calendars. The moon marked the passage of time long before clocks or written numbers. To early humans, the moon must have been one of the most mysterious and powerful things in existence. It changed. Every night it was slightly different. It grew from a thin silver sliver to a full bright circle, and then shrank back again. It moved across the sky. It lit the darkness softly, just enough to walk by, just enough to feel slightly less alone in the ancient night. Many cultures saw the moon as a living thing, a god or a goddess, a spirit moving through the sky, something to be respected, prayed to, listened to. They were not wrong to feel that way, not because the moon is a deity, but because the moon is genuinely powerful. Its influence on our world, on our tides, on our seasons, on the very beginning of life, is real and documented and deep. The ancient people who looked up and felt the moon was important were sensing something true, even if they explained it in different words than we use today. And how much more mysterious the sky must have been to the very first humans who ever looked up at it. A sky unchanged, or nearly unchanged, for hundreds of thousands of years before anyone thought to write anything down. Was there still a second moon then? No. By the time the first human beings existed, the second moon had been gone for over 4 billion years. The collision between the two moons happened so long ago that it was ancient even when the dinosaurs were alive. But somewhere, in the long, slow memory of the universe, the second moon is still real, still happened, still part of the story of how Earth came to be what it is today. For a moment, just breathe. Let the weight of that time settle over you, not like something heavy or frightening, but like a blanket, like the feeling of lying under an open sky on a warm night and feeling just for a moment how immense and quiet the universe is. We are part of this story too. Every person who has ever lived, every stone, every wave, every storm, every quiet moment like this one. We are all part of the same long, slow story that began when 2 moons circled a young and burning world. A sleep reset. If you're still listening, I want to take just a moment to check in with you. How does your body feel right now? Are your shoulders relaxed? Are your hands soft and still? Is there tension anywhere that you could gently let go of? Take a slow breath in. Breathe in all the way, filling your chest and your belly. Hold it for just a moment and let it out slowly. If your mind has been wandering to tomorrow's plans, to things left undone, to questions and worries that always seem louder in the dark, that is perfectly natural. Just gently, without judgment, bring your attention back to this voice, this story, this moment. You are safe. You are resting. There is nothing you need to do right now except be here. If you have already fallen asleep, that is wonderful. If you're just on the edge, drifting in and out, that is wonderful too. And if you're wide awake and listening carefully, that is also exactly right. There is no wrong way to listen to this story. We have covered a great deal of ground already. We have talked about the birth of the moon from the ancient collision with Theia. We have met the second moon, that smaller, quieter companion that may have circled the Earth for tens of millions of years. We have talked about how it may have slowly drifted toward the larger moon and merged with it, leaving behind the thick highlands of the far side. And we have talked about the Earth itself in those ancient days, the burning surface, the first rains, the slow beginning of the oceans. In the parts ahead, we will go deeper. We will talk about what the solar system looked like back then, and how the chaos of those early days shaped not just our moon, but our entire neighbourhood in space. We will talk about other moons in the solar system and what they tell us about our own. We will talk about the role the moon played in the story of life on Earth. But for now, in this quiet space between waking and sleeping, just let the images rest in your mind. 2 moons in an ancient sky, a young Earth glowing softly with heat slowly cooling, time moving with impossible patience toward the world we know. The world turns slowly and so do we. Let your breath be slow. Let your thoughts be soft. Let this story carry you a little further into the night there never was. The second moon rose and set over an empty Earth for millions of years. It did not need anyone to watch it. It didn't need to be remembered. It simply was, moving slowly through the ancient dark, doing its quiet work of shaping the world below. And then it rested too. Just as you're resting now. Tonight we're going to move outward a little. We're going to look at the neighbourhood around the young Earth. We're going to see the solar system as it was in those first few 100 million years, wild and crowded and full of movement. and we're going to follow the story of how, slowly, gradually, everything began to settle. Because the story of two moons is not just the story of the Earth and its sky. It is part of a much larger story. The story of how an entire solar system grew up. So get comfortable. Let your body sink a little deeper into wherever you're resting. Let your breathing be slow and even. We have a long, gentle road ahead of us tonight. Chapter 9. The Early Solar System. Imagine standing in space. Not the calm, quiet space you picture when you close your eyes. Not the deep, still darkness with its patient stars. Imagine space as it was 4.5 billion years ago. It is crowded. In every direction, there are objects moving. Huge chunks of rock and ice and metal, some the size of mountains, some the size of small countries, drifting and spinning and colliding with one another. The space between the planets is not empty. It is filled with debris, with the leftover material from the formation of the Sun, all of it slowly being drawn together by gravity into larger and larger shapes. Scientists call this period the Late Heavy Bombardment, though some now debate the exact nature and timing of it. What is clear is that the early solar system was a place of almost constant collision. Things ran into other things. Planets were struck again and again. Moons were formed, broken apart, reformed. It was, in a word, messy. The planets we know today, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, all of them were still finding their place. Their orbits were not yet the stable, predictable paths they follow today. They wandered, they shifted, they pulled on each other with their gravity in ways that changed their courses over millions of years. Jupiter, the largest planet in the solar system, played an enormous role in this early chaos. Its gravity was so powerful that it influenced the orbits of everything around it. It may have flung some objects inward toward the Sun, and others outward toward the edges of the solar system. It acted like a kind of cosmic traffic director, though not always a careful one. The young Earth, in the middle of all this, was being struck regularly, not gently. Enormous objects, some of them hundreds of kilometers across, hit the Earth and added their material to the growing planet. Each impact added more rock, more metal, more water locked inside minerals. Water, in fact, may have arrived on Earth partly from outside. Some scientists believe that many of the water molecules in Earth's oceans came from icy comets and asteroids that struck the planet during this early period. The water you drink, the water in the ocean, the water in the clouds above your head tonight, some of it may have originally formed in the cold outer reaches of the solar system, carried inward by small icy bodies that made the long journey to Earth billions of years ago. For a moment, just breathe. The water inside you has been on a very long journey. Chapter 10. The Moon's Early Life. Let us return to the Moon now, our Moon freshly formed from the debris of the Theia impact. In those first few million years after its formation, the Moon was very different from what we see today. It was much closer to the Earth. Right after the giant impact, the Moon may have been only a fraction of its current distance from us. Today the Moon is about 380,000 kilometers away, but in the early days it may have been only 20 or 30,000 kilometers away, perhaps even closer. Imagine the sky then. The Moon would have appeared enormous, not the small distant disk we see tonight, but a vast looming presence filling a large portion of the sky, its surface still partly molten, glowing with internal heat, its face huge and close and bright. The tides it would have pulled on those early oceans would have been extraordinary. Not the gentle tides we know today, but massive walls of water moving across the young ocean basins with tremendous force. The tidal energy would have been immense. Over time, that tidal energy slowly drained away. Every time the ocean tides moved, they transferred a tiny amount of energy from the Earth's rotation to the Moon's orbit. This is called tidal braking. The Earth's spin slowed down, and as it slowed, the Moon moved further away. This process is still happening today, very slowly. The Moon is currently moving away from the Earth at a rate of about 3 to 4 centimeters per year. That is roughly the same rate at which your fingernails grow. Tiny, imperceptible in a human lifetime, but real. In 1 billion years from now, the Moon will be noticeably further away. In several billion years, it may be far enough that it no longer perfectly covers the Sun during a solar eclipse. One of the most beautiful coincidences in nature. The fact that the Moon and the Sun appear almost exactly the same size in our sky, despite being vastly different in their actual size and distance. That coincidence is temporary, a brief window in the long story of Earth and Moon, and we happen to live exactly in that window. We are lucky in that quiet way that is easy to overlook. And if there were once 2 moons, both close to the Earth, both pulling at the ancient tides, the tidal forces in those early days would have been more complex still. The smaller second moon, orbiting perhaps at a different distance, would have added its own pull, its own rhythm to the movement of the early seas. The tides of a world with 2 moons would have been beautiful and strange. Chapter 11. What other moons teach us. Our solar system has many moons. Jupiter alone has at least 95 known moons. Saturn has over 140. Mars has 2 small moons, Phobos and Deimos, both of them tiny and potato-shaped, nothing like our large round moon. And by studying these other moons, scientists have learned a great deal about how moons form, how they behave, and what can happen to them over long periods of time. Some moons are captured asteroids, small rocky bodies that wandered too close to a planet and were caught by its gravity. Phobos and Deimos, the moons of Mars, are thought to be captured asteroids. They are small and irregular, and they orbit Mars in unusual ways. Some moons formed from disks of material around a planet, similar in some ways to the process that formed our own moon, though through different mechanisms, and some moons, it appears, formed from giant impacts, just like our moon. Scientists have found evidence that other planets in the solar system may have experienced their own giant impacts early in their history. The strange tilt of Uranus, it orbits the Sun essentially lying on its side, tilted nearly 90 degrees compared to the other planets, is thought to be the result of a massive collision early in its history. Something enormous struck Uranus and knocked it sideways, and it has been tilted ever since. Pluto, the dwarf planet far out at the edge of the solar system, has a large companion moon called Charon. Charon is so large relative to Pluto, more than half the size of Pluto itself, that some scientists consider them a double planet rather than a planet and its moon. Charon is thought to have formed from a giant impact as well, similar to the impact that formed our moon. So giant impacts, it seems, are not rare events in the history of the solar system. They happen many times in many places. The solar system was built in part through collision, and if our moon was formed from one such collision, and if that collision produced 2 separate moons rather than one, our own world fits neatly into a pattern that seems to repeat in different forms across the entire solar system. We're not an exception. We are an example of a process that the universe repeats again and again in its slow and patient way. For a moment, just breathe. Think about how many stories are happening simultaneously across the universe right now. How many worlds are circling how many stars? How many collisions have shaped how many planets that no human eye has ever seen? The universe does not need us to witness it. It simply continues. Patient, enormous, indifferent in its scale but somehow not in its detail, because the detail is where all the beauty lives. Chapter 12. the surface of the ancient moon. Let us visit the moon now. Let us travel there in our imagination and stand on its surface in those early days, when it was young and still warm from its formation. Imagine you're standing on the surface of the moon roughly 4 billion years ago. Beneath your feet, the ground is dark rock, solidified lava, rough and uneven. The sky above you is completely black, even though the sun is shining. The moon has no atmosphere, no air, nothing to scatter the sunlight into the blue colour we see on Earth. The stars are visible even in daytime, hard and bright, unblinking in the airless sky. The sun above you looks different. It is younger. It is slightly smaller and slightly dimmer than the sun we know today. Not dramatically different. You would still recognise it as the sun, but it is a little younger, a little less bright. And in the sky, enormous and close, hangs the Earth. Not the blue-green marble we see in photographs from space. Not yet. The Earth in those days is a different colour. Much of the surface is covered by lava and dark rock. The early atmosphere is thick with gases that absorb light in ways our modern atmosphere does not. The Earth may have looked brownish or greyish, or perhaps a strange deep orange in some light, but it is enormous. From the surface of the close young moon, the Earth would fill a huge portion of the sky. Its cloud formations, its volcanic eruptions, its still-forming oceans, all of it visible in extraordinary detail. You're standing on a small world looking up at a large one, and somewhere above you, in the black lunar sky, you might be able to spot a faint second shape. The smaller second moon, perhaps visible as a bright point of light, or perhaps large enough at certain times to show a visible disk against the stars. 2 worlds orbiting the Earth. You're standing on the larger one looking up at its smaller companion. This image will never appear in any photograph. No camera has ever captured it. No human being was ever there to see it. But the universe held this scene for millions of years, unhurried, unphotographed, real. And now, in the quiet of this night, you can hold it in your mind for a moment. Just breathe. A sleep reset. Let me pause here and check in with you. If you've been listening for a while now, your body has likely grown heavier. Your breathing has probably slowed without you even noticing. The muscles in your shoulders, your back, your legs, they have probably softened and let go of whatever tension they were holding when this evening began. That is exactly right. That is what the body wants to do when it is given permission. It wants to rest. It wants to let go. So let me give you that permission now. It is okay if you have missed parts of this story. It is okay if you drifted away and came back and drifted again. The story is not a test. There is no quiz at the end. There is no right way to listen. If your eyes are heavy, let them stay closed. If your thoughts are soft and drifting, let them drift. Take one slow breath in. Feel your chest rise, and let it fall slowly. The world is quiet right now. Whatever is outside, the night air, the distant sounds, the slow turning of the earth beneath you, all of it is going along just fine without your attention. You do not need to hold any of it together. It will manage on its own. You're allowed to rest. We will continue in a little while, moving through the story of how the solar system slowly settled, and what the disappearance of the second moon might have meant for the young Earth. But there is no hurry. There never was. Chapter 13. The Settling. Every storm eventually settles. The early solar system was a storm of unimaginable scale. 4.5 billion years of constant movement and collision, of things crashing into other things, of orbits shifting and planets migrating and moons forming and breaking apart. But slowly, over hundreds of millions of years, things began to calm. The large impacts became less frequent. The debris that had been floating between the planets, was either swept up by the planets themselves or flung out to the edges of the solar system or beyond. The orbits of the planets settled into stable, predictable patterns. This process of settling did not happen all at once. It was gradual, enormously gradual. The kind of gradual that makes human time feel like the blink of an eye. But it happened. And one of the most important aspects of this settling was the stabilization of the Earth-Moon system. After the giant impact, the Earth and the Moon went through a long period of adjustment. The Moon was close, then gradually moved further away. The Earth was spinning fast, then gradually slowed. The tides were enormous, then gradually became more moderate. And somewhere in that period of adjustment, perhaps within the first 100 million years after the Theia impact, the second moon merged with the first. The sky above the Earth simplified. Where there had been two, there was now one. One moon, larger now, carrying within its body the material of its former companion, moving through the sky in its slow, steady orbit, pulling the tides, stabilizing the seasons, lighting the ancient darkness with reflected sunlight. The world did not mark this moment. How could it? There was nothing yet to mark it. No living thing, no awareness, just the slow, quiet change of the sky. One day, if we can call it a day, the second moon rose above the horizon of the young Earth for the last time. It moved across the ancient sky, and before it could rise again, it was part of the larger moon. The night sky was different afterward, simpler, quieter, more like the sky we know today. Chapter 14. The First Life. Let us move forward in time now. Not a little, a lot. Let us drift through hundreds of millions of years, gently, without stopping at every detail, and arrive at one of the most extraordinary moments in the history of this planet. The beginning of life. About 3.5 billion years ago, perhaps even a little earlier, something remarkable happened in the young oceans of the Earth. Chemistry crossed a line. Molecules that had been forming and breaking apart and recombining for hundreds of millions of years finally arranged themselves into something new. Something that could do what nothing before it had ever done. It could copy itself. This is, stripped to its simplest form, what life is. The ability of a molecule or a collection of molecules to make copies of itself, to persist, to replicate. The first living things were not cells as we understand them. They were almost certainly simpler. Perhaps just strands of molecular material floating in warm water, able to copy themselves imperfectly, producing variations. And those variations, over enormous spans of time, were subject to the pressures of their environment. The ones that worked better survived. The ones that didn't fell apart. This is the beginning of evolution. This is the first chapter of the 4 billion year story that eventually, through a chain of changes so long and so complex that no single mind could ever trace it, produced every living thing that has ever existed on this planet. Every bacterium, every fern, every insect, every fish, every dinosaur, every flower, every bird, every person who has ever looked up at the moon and wondered. All of it from that first quiet moment of self-replication in the ancient ocean. For a moment, just breathe. The moon was already there when life began. The single moon settled into its orbit, pulling the tides along the ancient shores. Those tidal zones, the places where the ocean met the land, where water pulled back and forth twice a day, may have been exactly the kind of environment where early chemistry could concentrate and experiment. Rock pools full of minerals and water, warm during the day, cooler at night, wet, then dry, then wet again. Over millions of years, these pools may have acted like tiny laboratories, cycling through conditions that encourage the chemistry of life to develop. If the second moon had still been there, those tidal patterns would have been different, more complex. Whether that would have helped or hindered the beginning of life, we cannot say. Perhaps life would have found a way regardless. Life, as we have come to understand it, is remarkably persistent. But it is worth noting that the world that life was born into was a world with one moon. The settling of the solar system, the merging of the two moons, the stabilization of the tides, all of that happened before life began. The single moon, in a sense, welcomed life into the world. Chapter 15. The Moon in Human Memory. Let us make a great leap now, not backward, but forward. Far forward, through billions of years of slow life evolving, diversifying, spreading across the planet. Through the age of bacteria, the age of simple ocean creatures, the age of fish and insect and forests, the age of dinosaurs, the age of mammals, all the way to us, to the first human beings who looked up at the moon and felt something. We do not know exactly what they felt, but we can guess, because we still feel something when we look at the moon, something that does not quite have a simple word in any language, a mixture of wonder and smallness and beauty, a sense that the moon is watching or listening or simply being there in a way that feels important. Every culture in human history has had something to say about the moon. In ancient Mesopotamia, the moon was a god called Sin, one of the most important deities in the pantheon. The city of Ur, one of the earliest cities in human history, had a great temple dedicated to the moon god. People prayed to the moon for safety, for harvest, for guidance in the dark. In ancient Egypt, the moon was associated with Thoth, the god of wisdom and writing and time. The phases of the moon were used to keep calendars, to track the planting seasons, to organize religious festivals. In ancient China, the moon was associated with a goddess named Chang'e, who according to legend drank an elixir of immortality and floated up to live on the moon forever, accompanied only by a jade rabbit. It is one of the most enduring myths in Chinese culture, still celebrated today in the Mid-Autumn Festival, when families gather to look at the full moon and eat round moon cakes. The ancient Greeks associated the moon with several goddesses, most notably Selene, who drove a silver chariot across the night sky, and Artemis, goddess of the hunt and the wild places. In Roman mythology, the moon goddess was Diana, the huntress. Across cultures that had no contact with one another, separated by oceans and mountain ranges and thousands of years, human beings looked up at the same moon and felt its presence, built stories around it, made it part of their understanding of the world. That is remarkable. That is worth pausing over. The moon has been a companion to human beings from the very beginning of human history. Before writing, before cities, before agriculture, people gathered around fires and looked up at the moon and made meaning from its light. And that moon, the one they watched, the one they worshipped and wondered about, carries within its body the remains of a second moon that circled the Earth, billions of years before the first human being ever drew breath. For a moment, just breathe. The moon is older than our stories, older than our species, older than the first living thing that ever moved through the ancient ocean. And yet, in every generation it is new to someone. Every child who looks up at the moon for the first time and points and says a word that means bright, or round, or there, every single one of them is seeing it as if it has just appeared. Fresh, wonderful, mysterious. The moon does not grow old in the eye of the beholder. That is another kind of beauty. Chapter 16. The Far Side and What It Holds. We have talked about the far side of the moon before, the side that always faces away from Earth, the side we never see. Let us spend a little more time there. When the Soviet spacecraft Lunar 3 photographed the far side of the moon for the first time in 1959, it was one of the genuinely astonishing moments in the history of exploration. For the entirety of human history up to that point, The far side of the moon had been completely unknown. No telescope could see it. No observer on Earth could ever watch it directly. And then, suddenly, photographs. Blurry, imperfect photographs by modern standards, but photographs nonetheless. The far side revealed itself for the first time to human eyes. It was different from what many had expected. Instead of the relatively smooth dark plains visible on the near side, the far side was almost entirely covered in craters and highlands. Rough, ancient, battered terrain. The lava plains that cover so much of the near side were almost entirely absent on the far side. This asymmetry became one of the most discussed puzzles in lunar science. How could one side of the same moon be so different from the other? One early idea was related to the difference in heat. The near side of the moon faces the Earth, and in the early history of the moon, the Earth was much warmer and much closer. Some scientists thought the extra heat from the nearby Earth might have kept the near side's crust thinner and more susceptible to volcanic activity, allowing lava to flood the plains and create the Maria we see today. That is a reasonable partial explanation, but it may not be the whole story. The two-moon hypothesis of Jutzi and Asfaug offers something additional. If the second moon smashed slowly and gently into the far side, it would have added a thick layer of material to that hemisphere. This added material, lower in radioactive elements, which are the source of internal heat in rocky bodies, would have created a far side crust that was thicker and less prone to volcanic flooding. The material that flooded the near side's plains came from volcanic eruptions driven by the heat of radioactive decay deep inside the moon. If the far side had a thicker crust, the lava could not break through as easily. The far side stayed rough and ancient, while the near side was partly resurfaced by lava flows. The result, billions of years later, is the asymmetric moon we see and measure today. If this hypothesis is correct, then the face of the moon as we know it, the familiar man-in-the-moon pattern of dark plains and bright highlands, was partly shaped by the collision with the second moon. The map we know is a record of that ancient meeting. Every time you look up at the full moon, you're looking at the visible signature of an event that happened over 4 billion years ago. The dark patches, the bright highlands, they're telling a story. For a moment, just breathe. Think about the things in your own life that are shaped by things you cannot see, by events from your past, or your parents' past, or generations before, by choices made before you were born that set the conditions for everything that followed. The moon is shaped by something that happened before life existed, and yet that shaping is there, visible, real, every single time we look up. We carry our histories in our faces too. Chapter 17, Quiet Reflection on Deep Time. I want to take a moment here, as we move toward the end of this second part of our story, to reflect on something quietly profound. We've been talking about events that happened billions of years ago, and I think it is worth sitting with what that actually means for a moment. Not to be overwhelmed by it, not to feel small in an unhappy way, but just to feel it. 4.5 billion years. If you were to compress the entire history of the Earth into a single year, a calendar year, from January 1st to December 31st, then the formation of the Earth and Moon would happen on January 1st. The first simple life would appear sometime in late February or early March. The first complex cells with a nucleus like the cells in our bodies, would not appear until roughly July or August. The first animals would appear in mid-November. The dinosaurs would appear on December 10th and go extinct on December 26th. All of recorded human history, every war, every invention, every story ever written down, every building ever built, would take place in the last 14 seconds of December 31st. We are 14 seconds in a year, and the second moon, the one we have been talking about all night, was gone before March even began. It was an event of January, the deepest, most ancient January imaginable. For a moment, just breathe. There is no need to feel frightened by that scale. It is not meant to diminish you. It is meant to offer you a kind of rest. Because if you can feel, even for just a moment, how vast this story is, and how brief your own chapter within it is, then the things that seem urgent and large and pressing in your daily life may feel just for a moment a little lighter. The second moon came and went before life began. The earth continued. Life began anyway. Everything found its way, and so will you. The world turns slowly, and so do we. If your breathing is slow now, if the thoughts in your mind are soft and drifting, let them drift. Let them go where they want to go. You do not need to hold on to this story or remember every detail. The story will be here when you return, and if you're asleep before the next word, then the story has already done its most important work. Rest now. Let the ancient sky above the young earth settle into your imagination. 2 moons, moving slowly. The earth below, patient and warm. Time, stretching in every direction with no edges. And you, here, now, small and warm and briefly, wonderfully alive. The world turns slowly, and so do we. We will continue soon. There is more to this story. There are more chapters ahead, about the oceans that formed under the 2-moon sky, about what happened when the solar system's chaos began to calm, about the strange and beautiful ways the moon has guided life on Earth for billions of years. But for now, just breathe. Just rest. The second moon is still out there in a way, locked into the body of the moon we know, carried through time in the thick crust of the lunar far side, turned into part of something larger. And isn't that, in the end, what all of us do? We become part of something larger. We drift. We rest. We let go. And the world goes on, slowly, gently, as it always has. You are still here. And that is a lovely thing. Whether you drifted away for a while and have just floated back, or whether you have been listening quietly all along, welcome. The story is still here. The night is still soft around you. And there is no hurry. Take one slow breath in. Feel your chest rise, just gently, and let it fall. We have travelled a long way together already. We have watched the young earth burn and cool. We have seen the second moon form from the debris of an ancient collision. We have watched the 2 moons circle together in a sky that no living thing ever saw, and we have followed the slow, quiet merging that left the far side of the moon thick and ancient with the material of its lost companion. We're going to drift a little further. We're going to look at the ocean that formed beneath that ancient 2-moon sky. We're going to visit some of the strangest and most beautiful periods in Earth's long history. We're going to think about what the moon, our single, familiar moon, has done for the living world over billions of years, and we're going to let the story grow slower and quieter as we move through it, like a river widening as it nears the sea. So settle in, let your hands rest soft, let your jaw unclench just a little. We're drifting into part 3 now, chapter 18, The Ocean Beneath 2 Moons. There is a moment in the history of the Earth that is hard to name precisely, because it happened over millions of years rather than on a single day. But if you had to choose a moment to mark the change, you might choose the moment when the first raindrop fell on the young Earth and did not immediately turn back into steam. The moment the ocean began. The surface of the early Earth had been cooling slowly for hundreds of millions of years. The lava oceans were hardening into rock. The thick, hot atmosphere was beginning gradually to thin, and the water that had been locked inside the planet's rocks, slowly escaping as the vapour, was starting to find that the air was cool enough, just barely cool enough, to let it fall as rain and stay. At first, just small pools, shallow and warm and probably quite acidic, nothing like the blue ocean we picture, more like a series of warm, mineral-rich ponds scattered across a dark volcanic landscape. But the ponds grew, they connected, the rain kept falling. The rivers, if we can call them rivers, on a world without any living thing, carved channels through the new rock and carried water toward the lowest places, and the lowest places filled. The first oceans were probably warm, perhaps quite hot in some places. The seafloor was still volcanically active, with heat escaping from the interior of the earth through cracks and vents. The chemistry of this early ocean was nothing like today's seawater. It had different concentrations of minerals, different temperatures, a different chemical balance entirely, but it was water, liquid, flowing, pooling, moving. And above it the sky held 2 moons. Imagine standing at the edge of that ancient sea. The water is warm and slightly murky. The rock beneath your feet is dark and rough. The sky above is a strange heavy colour, not the blue we know, because there is very little free oxygen in the atmosphere yet. Perhaps a pale orange or a dusty brownish haze. The sun, a little smaller than we know it, hangs above the horizon. And as the sun sets and the sky darkens, 2 shapes appear. The larger moon, bright and familiar in shape, though closer than we know it today. And above or below it in the sky, or off to one side, the smaller companion, dimmer, quieter, a softer glow. The tides that these 2 moons would pull on the early ocean are difficult to calculate precisely, because we do not know exactly how far apart the 2 moons were or how far from Earth. But scientists who have modelled this scenario suggest the tidal forces would have been significantly stronger and more complex than today. Today, our tides are primarily driven by the moon, with a smaller contribution from the sun. 2 moons would have created competing tidal rhythms, overlapping and interfering with each other in patterns that changed over days and weeks and months. High tide and low tide would not have been the simple, predictable, twice-daily rhythm we know today. They would have been more varied, sometimes stacked together, a very high tide when the 2 moons were aligned, sometimes partially cancelling each other out, a more moderate tide when they were pulling in different directions. The shoreline of the early Earth would have experienced a complex, shifting pattern of flooding and draining. For a moment, just breathe. Picture that ancient shoreline, dark rocks covered in warm, mineral-rich tide pools, the water pulling back to reveal wet stone, then rushing back in again, pulling back, rushing in, day after day, year after year, century after century, million after million of years. No one watching, no one naming it, just water and rock and time. Chapter 19. The Chemistry of Beginnings. This is where the story begins to turn towards something extraordinary. Those tide pools, those warm, shallow, mineral-rich pools that filled and drained with each tide, may have been among the most important places in the entire history of life on Earth. Here is why. For life to begin, certain things need to happen. Complex molecules need to form. These molecules need to find each other. They need to interact in new ways, and they need to do this over and over again in slightly different ways each time until eventually something forms that can copy itself. This is not easy. It requires the right chemicals, the right temperatures, and, perhaps most importantly, the right conditions for concentration and repetition. In the open ocean, molecules tend to drift apart. The vast volume of water dilutes everything. A molecule formed in one place is quickly separated from the molecules it needs to interact with. But in a tide pool, something different happens. When the tide comes in, it brings new minerals and organic molecules from the ocean. When the tide goes out, the pool is left behind, In the heat of the sun, the pool can partially evaporate, concentrating its chemicals. Then the tide comes back in and dilutes them again. Then the sun evaporates again. Then the tide returns. This cycle of concentration and dilution, over and over and over again, creates conditions for chemical experimentation on an enormous scale. Millions of pools, billions of tidal cycles, trillions of chemical reactions, and all of this happening potentially under a sky with 2 moons. With tides that were more complex, more varied, more energetic than today's. Some scientists believe that the greater tidal energy of the early Earth, before the 2 moons merged, and while the single moon was still closer to Earth, may have actually been beneficial for the origin of life. More tidal mixing, more varied conditions, more opportunities for chemistry to try new combinations. We cannot be certain. The origin of life remains one of the deepest unsolved mysteries in all of science. We know it happened. We know roughly when it happened. But the precise chain of chemical events that led from non-living molecules to the first self-replicating thing, that chain is still being investigated, still debated, still full of open questions. But the tides were there. The moon, or the moons, were there. And wherever life began, the pull of those ancient moons was part of the environment. For a moment, just breathe. The moon helped shape the conditions for life, and life, eventually, produced beings who could look up at the moon and wonder where it came from. There is a kind of circle in that, a long, slow, ancient circle. Chapter 20. The Long Quiet. After life began, something remarkable happened. Almost nothing happened, for a very, very long time. The first living things were bacteria, simple single-celled organisms. They had no nucleus, no complex internal structure. They were, compared to the cells in your body, extraordinarily simple, and for roughly 2 billion years, bacteria were essentially all there was. 2 billion years. Remember our earlier calculation, where we compressed Earth's history into a single year. In that scale, bacteria ruled the Earth from approximately late February until late July. 5 months of slow, quiet bacterial life. No animals, no plants, no fungi, no complex cells. Just bacteria, endlessly reproducing, spreading across every surface and into every ocean, quietly changing the chemistry of the world. This period, called the Proterozoic and the earlier Archean eons, is often called the boring billion by scientists with a sense of humour. Though calling it boring rather undersells what was actually happening. Because during this long, quiet stretch of time, bacteria were performing one of the most world-changing acts in the history of the planet. They were filling the atmosphere with oxygen. Before bacteria, the atmosphere of the Earth had almost no free oxygen. Oxygen was present, but locked into rocks and water molecules, not floating free in the air. The air was primarily nitrogen and carbon dioxide with various other gases. But a type of bacteria called cyanobacteria developed the ability to use sunlight to produce energy, a process we call photosynthesis. And a byproduct of photosynthesis is oxygen. These bacteria began releasing oxygen into the atmosphere, slowly at first. Then, as they spread across the oceans, in larger and larger amounts. Over hundreds of millions of years, the oxygen concentration in the atmosphere increased. This event is called the Great Oxidation Event, and it changed everything. For many of the bacteria living at the time, free oxygen was actually toxic. Oxygen is a reactive gas, and organisms not adapted to it can be harmed or killed by it. The Great Oxidation Event caused one of the first mass extinctions in the history of life, wiping out many of the ancient bacterial communities that had thrived for so long. But it also opened the door for everything that came after, because oxygen in the atmosphere made possible the development of complex energetic life. The cells in your body use oxygen to produce energy, much more efficiently than the older methods bacteria had used. Without oxygen, complex multicellular life like us would be impossible. The bacteria changed the world so that something else could live in it. They did not do it on purpose. They had no plans or intentions. They simply lived and reproduced and breathed out oxygen for 2 billion years. And the world was transformed. For a moment, just breathe. The air you're breathing right now, the oxygen filling your lungs in this quiet moment, is the legacy of 2 billion years of bacterial life. Ancient, patient, unthinking, but transformative beyond any human achievement. The world turns slowly, and sometimes the slowest changes are the deepest ones. Chapter 21. The Moon's Steady Presence. Through all of this, through the 2 billion year age of bacteria, through the Great Oxidation Event, through the first complex cells and the first animals and the first forests, the Moon was there, moving through its orbit, pulling the tides, stabilizing the seasons, reflecting the sunlight back at a world that slowly was filling with life. The Moon is often taken for granted. It is so familiar, so constant, so much a part of the background of human experience that it is easy to forget what an extraordinary and important presence it is. Let me remind you of a few things the Moon does for us. The Moon stabilizes the tilt of the Earth's axis. This is enormously important for life. The Earth is tilted at approximately 23.5 degrees relative to its orbit around the Sun. This tilt is what causes the seasons. In summer, your hemisphere is tilted toward the Sun. In winter, it is tilted away. Without the Moon's stabilizing gravitational influence, this tilt would not stay constant. Computer models suggest that without the Moon, the tilt of the Earth could wander chaotically, sometimes becoming very small, which would reduce seasons dramatically, and sometimes becoming very large, which would cause extreme seasonal swings, with blazing summers and frozen winters far more intense than anything we experience today. Life has evolved to fit the conditions on Earth as they are, not as they might be if everything were different. The seasons we have are the seasons our ecosystems are built around. The tides we have are the tides that shaped our coastlines. The length of our days is built into the circadian rhythms of virtually every living thing on the planet. The Moon made all of this possible. And perhaps before the Moon was a single moon, when it was 2 moons circling together, the Earth's conditions were different enough that the history of life, if it began at all, would have taken a different path. We will never know exactly what that path might have been. But we can appreciate the path we're on. A sleep reset. Let me take a moment here to check in with you. How are you doing? Has the night grown deeper around you? Has your breathing settled into a slow, easy rhythm? If you're listening to this in the dark, I want you to imagine, just for a moment, that the ceiling above you is transparent, that you can see through it to the sky above, and that in the sky, the Moon is there, that single, familiar Moon, moving slowly through the dark. Somewhere out there, the same Moon that has looked down on every sleeping human being in all of history is looking down on you tonight. That is not a small thing. For a moment, just breathe. If your thoughts have been drifting, let them drift. If your body feels heavy, let it be heavy. There's nothing to hold on to tonight, nothing to figure out. The story will carry you. Notice your breathing, slow, in and out, in and out. Let the images from this story rest gently in your mind. The ancient ocean, the tide pools, the bacteria breathing oxygen into a world that did not yet know it needed it. The Moon, always there, patient and bright. You do not need to remember any of this to benefit from it. The quiet, slow rhythm of the story is the point. The facts are just the texture of the dream. Rest now, just for a moment, and when you are ready, we will continue. Chapter 22. The deep ocean. Let us go somewhere quiet now. Let us go down into the ocean. Not the surface of the ocean, with its waves and light and wind. Let us go deeper, much deeper. Down through the sunlit zone where photosynthesis happens, and fish swim, and the water is blue-green and bright. Down through the twilight zone where the light fades and the creatures are stranger. Down through the midnight zone where no sunlight penetrates at all, and the water is very cold and the pressure is enormous, and the darkness is complete. Down, finally, to the seafloor. The deep seafloor is one of the least visited places on Earth. We have better maps of the surface of the moon than we do of the bottom of our own ocean. The deep ocean is vast and dark and cold, and getting there requires extraordinary technology and considerable difficulty. But what scientists have found in the deep ocean when they have managed to visit it is extraordinary. On the seafloor, in places where volcanic heat escapes from the Earth's interior, there are hydrothermal vents. Cracks in the rock where superheated water, rich in minerals, pours out into the cold deep ocean. Around these vents, in complete darkness, far from any sunlight, there is life. Not just a little life, a rich, complex, diverse community of life. Tube worms meters long swaying gently in the warm currents near the vent. Shrimp clustered by the thousands around the mineral-rich outflows. Crabs picking their way across the dark rock. Bacteria forming thick mats on every surface. None of this life uses sunlight. It uses chemical energy from the minerals in the vent water. It is entirely independent of the sun, and here is why this matters to our story. Some scientists believe that life on Earth may not have begun in the surface tide pools at all. Instead, they think life may have begun in places very much like these deep-sea hydrothermal vents, in the warm, dark, chemically rich water around these ancient cracks in the seafloor. No sunlight required, no tides, just chemistry and heat. Other scientists believe life began at the surface, in those tidal pools we talked about earlier. And still others think life may have originated in multiple places at once, with different molecular experiments happening simultaneously in different environments. The honest answer is that we do not know. Not yet. But what both possibilities share is a need for liquid water, for chemical gradients, differences in temperature and chemistry that can drive reactions, for time, an enormous amount of time. And time, in the story of the Earth, is something there has always been plenty of. For a moment, just breathe. The ocean floor tonight is doing what it has always done. Dark, cold, unhurried, creatures moving through the blackness in ways that no human eye will ever see. Chemistry proceeding without witnesses, life in its patient and relentless way going on. The world is far larger and far stranger than the small slice of it we inhabit in our daily lives, and that is not frightening, it is restful. Chapter 23. Moonlight and memory. I want to talk for a moment about moonlight. Not about the science of it, though the science is interesting. Not about the physics of light reflection or the albedo of the lunar surface. Just about moonlight itself, the experience of it. Have you ever stood outside on a clear full moon night and just looked at the light it cast? Moonlight is not like any other light. It is not like sunlight, which is bright and warm and clearly directional. It is not like lamplight, which is warm and close and intimate. Moonlight is something different. It is cool. It is diffuse. It softens edges and smooth surfaces. Colours in moonlight are muted, shifted towards silver and grey and pale blue. Shadows in moonlight are soft, not sharp. There is a quality to moonlight that does something to the mind, something calming, something that makes the ordinary world look slightly different, slightly magical, slightly removed from its usual self. scientists have actually studied the effect of moonlight on sleep and on human behaviour. The full moon, some researchers have found, does affect sleep, though modestly. Around the time of the full moon, people in studies tended to take slightly longer to fall asleep and to sleep slightly less deeply. The effect was small but real. The moon, even today, even when we live in houses with thick curtains and electric lights, still reaches us, still affects us, in ways we may not even notice. Imagine living without electric lights. Imagine living in a world where the moon was the primary source of nighttime illumination. The full moon, in those conditions, was not just beautiful. It was practical. It meant you could travel at night. It meant you could see well enough to work, to hunt, to find your way home. In agricultural societies, the full moon in harvest season was especially important. It gave farmers extra hours of light to gather their crops before the autumn weather changed. This is why the full moon closest to the autumn equinox is called the harvest moon. The moon gave people time. It extended the day into the night gently, softly, without the harshness of fire or the artificiality of electric light. Just that cool, silver, patient glow. For a moment, just breathe. If there's any moonlight reaching you right now, through a window, through a gap in the curtains, notice it, or simply imagine it. That cool silver light falling across the floor, the same light that has fallen across the floors of 1 billion nights before this one, the same light that fell on ancient cities, on quiet forests, on empty deserts, on the first human beings who ever felt safe enough to sleep. You're inside a very long story tonight, and you are one of the lucky ones who gets to rest. Chapter 24, The Far Side Forever. Hidden. There is something I find endlessly fascinating about the far side of the moon, and I want to return to it one more time before we move on. The far side of the moon has never been visible from Earth. Not once in all of human history. Not from the time the first human beings looked up at the sky. Not from the time of the ancient Mesopotamians and their moon temples. Not from the Greeks and their moon goddesses. Not from the medieval scholars who mapped the stars. Not from Galileo, who turned one of the first telescopes toward the moon in the early 17th century and saw craters and mountains in extraordinary detail. None of them ever saw the far side. It was simply there, turned away, unknown, a permanent secret kept by the mechanics of orbital physics. The reason the same face of the moon always points toward us is something called tidal locking. The gravitational pull of the Earth has, over billions of years, slowed the rotation of the moon until its rotation period exactly matches its orbital period. It takes the same amount of time for the moon to spin once on its axis as it does to orbit the Earth once. So as the moon goes around the Earth, it always shows us the same face. This is not a coincidence. This is a result. The tidal forces between the Earth and the moon, acting over billions of years, gradually synchronize the moon's rotation to its orbit. Many large moons in the solar system are tidally locked to their planets in the same way. Our own moon, the large moons of Jupiter, the large moons of Saturn. Tidal locking is common throughout the solar system, but what it means for the far side of our moon is that it has existed, unknown and invisible, for the entirety of human experience. For hundreds of thousands of years, human beings stared up at the moon, watched it through telescopes, wrote poems and songs and prayers about it, and had absolutely no idea what was on the other side. And then, in 1959, the Soviet spacecraft Lunar 3 made its careful way around the moon and pointed a camera backward. And the far side was revealed. It was rough, it was ancient. It was covered in craters and mountains and highlands, with almost none of the dark plains that cover the near side. And now we know, or at least we have a very good reason to believe, that the roughness of the far side may be the legacy of the second moon. that those ancient highlands are the remnants of a body that no longer exists as a separate world, that the far side of the moon is carrying, in its thick and cratered crust, the last physical evidence of a sky that has not existed for over 4 billion years. The far side has been turned away from us for billions of years, but it remembers. For a moment, just breathe. Think about the things you carry that are not visible to anyone else, the quiet histories inside you, the experiences that shaped your face and your voice and the way you move through the world without anyone ever seeing exactly where they came from. We are all, in some way, like the moon. We show one face to the world, and the other side is ancient and textured and full of histories that no one can quite see, but that shaped everything. Chapter 25. What we've lost and what remains. As we move toward the end of this third part of our journey, I want to sit for a moment with the idea of loss. The second moon is gone. There is no gentle way to say that. Something that once existed in the sky of this world no longer exists as a separate thing. It is possible, of course, to say it was not truly lost, that it became part of the larger moon, that its material is still there, that nothing was destroyed, and that is true. In a physical sense, nothing was lost. The atoms that made up the second moon are still in the universe. They are in the far side highlands. They are scattered across the lunar surface. Some may have ended up on Earth itself, carried down over billions of years by various slow processes. But as a distinct world, as a shape in the sky, as a separate moon with its own face and its own orbit and its own quiet presence, it is gone, and the sky is different for its absence. There is something worth acknowledging in that. Not with grief exactly, more with a kind of quiet acknowledgement. A recognition that the universe is constantly changing, constantly losing things and gaining others, constantly transforming one state into another. Stars form and burn for billions of years and then collapse or explode. The material of those stars drifts through space and eventually becomes part of new stars, new planets, new moons. Nothing is permanent. Nothing stays exactly as it was. The second moon was part of this process. It formed, it circled the Earth, it merged with its companion, and it became part of something that has lasted for over 4 billion years since. That is not a sad story. It is a transformation story. And transformation is not loss, it is continuation. For a moment, just breathe. Think about the things in your own life that have transformed. The people you used to be, the places you used to live, the versions of things that no longer exist in exactly the same form. Nothing is truly gone. It is just different now. The energy persists, the effects persist. The ripples from every event spread outward through time and do not stop. The second moon changed the face of the moon we look at tonight. The tide pools it helped fill were part of the environment where life may have begun. The complex tidal patterns it created shaped the early Earth in ways we're only beginning to measure. Its effects are still with us. Just as the effects of every moment in your own life, no matter how small or how long ago, are still with you now, the world turns slowly, and nothing is truly lost. It just becomes part of what comes next. Chapter 26. A long quiet night. Let us rest here for a moment. We have covered a great deal of ground in this third part of our story. We have visited the ancient ocean, just forming beneath the two-moon sky. We have thought about the tide pools and the chemistry that may have led to the first life. We have drifted through 2 billion years of bacterial patience. We have gone deep into the ocean and found life in the darkness. We have stood in moonlight and felt what our ancestors felt standing in the same light. We have thought about the far side of the moon and what it holds. And we have thought gently about transformation and loss, and the ways that everything that seems to disappear is really just changing shape. It is a lot to carry, and you do not need to carry it. Let it rest. Let the images settle like leaves floating slowly down through still water, finding their places on the floor without any effort. Your body knows how to rest. It has been resting every night for your entire life. It does not need instructions, it just needs permission. So here is your permission. Let go of the story for now. Let go of the science and the ancient moons and the tide pools and the far side highlands. Let go of everything you are supposed to remember today and everything you need to do tomorrow. Just breathe in and out. The moon is out there tonight. That single familiar moon, carrying within it the quiet legacy of its ancient companion, moving through its orbit at the same slow, patient pace it has kept for 4 billion years. You are here. Briefly, wonderfully, impossibly here. One small, warm, breathing thing in the long story of a world that began with fire and slowly became this. Became green hills and blue oceans and quiet nights and the sound of someone breathing slowly beside you. The world turns slowly and so do we. You came back. Or perhaps you never left. Perhaps you have been here the whole time, drifting in that soft, warm space between listening and sleeping, where the words become less like information and more like weather, like something you feel rather than follow. Either way, you're welcome here. Take one slow breath in. Let it out slowly. We have travelled a long way together now. 3 long parts of this journey already behind us. We're going to do something a little different. We're going to slow down even more. We're going to let the story breathe more openly. We're going to spend more time simply reflecting on what we have already learned, turning it over gently in our hands like a smooth, warm stone, feeling its weight and its texture rather than always reaching for the next new thing. There will still be new chapters, still new ideas, new images, new quiet wonders to explore, but the pace will grow softer from here. The information will thin out like mist in the morning, slowly giving way to something more open and still. Think of it as the part of the night when the stories stop trying so hard and simply become the sound of a voice in the dark. So get comfortable. Adjust your pillow or your blanket or whatever softness is around you. Let your body settle one more time into its most natural resting position. We are beginning part 4 now. Chapter 27. The cooling world. Long after the 2 moons became one, long after the second moon merged quietly into the far side highlands of its larger companion, the Earth was still a young and restless place. But it was changing. The word that comes to mind when I think about this period in Earth's history is settling. Everything was settling. The way a house settles in the night, making small sounds as the temperature changes, as the wood and stone find their natural resting places, as the stress in the structure slowly eases. The Earth was doing something like that, on an enormous scale, over hundreds of millions of years. The surface, which had been largely molten in the very early days, had cooled enough to form solid rock, not stable, quiet rock like you find in a mountain today. Still very active rock, still volcanic, still shifting and moving and cracking and reforming, but solid. The first continents were beginning to form. This is another one of those events that is almost impossible to date precisely, because it happened so slowly. But somewhere in the first billion years of Earth's history, large masses of relatively light rock began to float above the denser rock of the ocean floor, rising slightly, forming the first hints of what would eventually become continents. These early continents were nothing like the continents we know. They were smaller, lower, more scattered. They did not have the high mountain ranges or deep river valleys or broad plains of today. They were just patches of lighter rock rising slightly above the shallow early oceans, but they were there, and over billions of years those patches of rock would drift and collide and merge and split apart again in a slow, grinding dance called plate tectonics. The continents as we know them, North America, South America, Europe, Africa, Asia, Australia, Antarctica, are just the current configuration of that dance, a snapshot taken at this particular moment in the long performance. In the deep past, the continents were arranged very differently. There was a time, roughly 300 million years ago, when all the continents were joined together in one enormous supercontinent called Pangaea. And before Pangaea, there were other configurations, and before those, others still. And in the far future, the continents will continue to drift. In 100 million years, the map of the world will be unrecognizable. For a moment, just breathe. The ground beneath you is moving, not fast enough to feel, not fast enough to notice in a lifetime, but moving, drifting, being carried slowly on great plates of rock floating on the partially molten mantle beneath. You are, in a very literal sense, a passenger. We all are. Chapter 28. The Gift of a Tilted World. I want to come back gently to the moon's role in our daily lives, because I think it deserves more time. We talked earlier about how the moon stabilizes the tilt of the Earth's axis, and I want to expand on that a little, because the implications are deep and quiet and beautiful. The Earth is tilted at 23.5 degrees. This tilt, maintained by the gravitational steadiness of the moon, is what gives us seasons. Think about what seasons mean. Really think about it slowly. In spring, the world wakes up. Seeds that have waited all winter in the frozen ground begin to sense the lengthening days and the warming soil. They push upward. Flowers open. Birds return from distant places they travelled to in autumn. Baby animals are born. The whole living world takes a long, slow breath and begins again. In summer, the days are long and full. The sun stays in the sky for hours and hours. Plants grow tall. Insects fill the air with sound. Everything is warm and abundant and busy in a way that feels, on a good day, almost overwhelming in its richness. In autumn, the world turns. The light changes first, that soft, golden, slanted light of October that is different from any other light in the year. Then the colours change. Leaves turn yellow and red and orange and fall quietly to the ground. Animals gather food for the coming cold. The world is preparing, and in winter everything rests. The trees are bare, the fields are quiet, the days are short and the nights are long. The world goes inward, and there is something in winter, in the bare simplicity of it, in the long dark evenings and the cold clean air. That is its own kind of beauty. All of this, every season, every spring morning and summer afternoon and autumn evening and winter night, all of it is made possible by that 23.5 degree tilt, and that tilt is held steady, reliably, century after century, by the gravitational presence of the moon. Without the moon, the tilt would wander, and without a stable tilt, the seasons as we know them would not exist. They might be extreme one century and minimal the next, unpredictable, chaotic. Life would need to adapt to conditions that kept changing in ways too fast and too large to easily accommodate. Life might still exist on such a world. Life is remarkably creative, but it would be different, perhaps very different. The seasons we love, the seasons that poets have written about for thousands of years, the seasons that structure our agriculture and our festivals and our sense of the year turning, are a gift from the moon, not a conscious gift. The moon does not know it is doing us a favour, but the effect is real. For a moment, just breathe. Think about your favourite season. Think about the feeling of it. the particular quality of the light or the air or the sounds that belong to that time of year. That season exists in part because of the moon. The world is more connected than it looks. Chapter 29. Small Creatures and Deep Time. At some point in the story of Earth, something happened that is very easy to say quickly and very difficult to truly feel. Complex life appeared. About 600 million years ago, after those 2 billion years of patient bacterial existence, something changed in the ocean. The first complex multicellular animals appeared. Not large, not impressive looking by our standards. Small, soft, mostly strange. Some of them look like fronds or ferns. Some look like nothing alive today. Some were simple tubes or mats or discs. But they were multicellular. They were made of many cells working together in coordinated ways, and that was new. This period is called the Ediacaran, and the creatures of this time are called the Ediacaran biota. They are deeply strange. When their fossils were first discovered in the rocks of the Ediacara Hills in Australia and in other places around the world, scientists were not always sure they were even animals. Some thought they might be a completely different kind of life, unrelated to any living thing today. We now believe many of them were early animals, or at least close relatives of animals. But they were so different from modern life that drawing a direct line from them to us requires a great deal of imagination. Then, roughly 540 million years ago, something called the Cambrian explosion happened. It was not actually an explosion. It happened over about 20 million years. But in geological terms, that is fast. Extremely fast. In this relatively short period, the diversity of animal life on Earth multiplied enormously. Body plans that had never existed before appeared in the fossil record. Eyes, shells, legs, mouths designed for eating other animals. The basic blueprints for nearly every major group of animals alive today trace back, in some form, to the Cambrian period. No one fully understands why this happened when it did. Some scientists point to changes in oxygen levels. Some point to changes in ocean chemistry. Some suggest that the evolution of predation, animals eating other animals, triggered an arms race of development, with creatures rapidly evolving new defenses and new strategies to survive. And some, quietly, wonder whether the stability of the Earth's environment, including the stability of its seasons maintained by the moon, played a role in allowing this explosion of complexity to occur. We cannot know for certain. The Cambrian explosion is another of those mysteries that science has described clearly and explained only partially. But it happened, and from those strange Cambrian creatures, in a chain of changes stretching across 500 million years, came every animal that has ever walked or swum or flown, including us. For a moment, just breathe. You're 540 million years in the making, at least. If you count the bacterial ancestors before the Cambrian, you are 4 billion years in the making. Every night you rest, you're resting within a story of unimaginable depth. Chapter 30. The Moon and the Tides of Life. There is a thread I want to follow a little further. The thread of the moon and life. We have talked about how the moon may have helped create the tidal conditions for the origin of life. We have talked about how the moon stabilizes the seasons and makes the Earth a more predictable, livable place. But there are other ways the moon has woven itself into the fabric of life on Earth. Many animals time their behavior by the phases of the moon. Sea turtles come ashore to lay their eggs in patterns related to the lunar cycle. Certain corals release their eggs and sperm into the ocean in massive coordinated spawning events that are triggered by the full moon. Some fish spawn only during particular moon phases. Many insects are more active during the full moon, when the additional light makes navigation easier. The lunar cycle, which is approximately 29.5 days long, echoes through the biology of many living things. And remarkably, The human body shows traces of this too. The word menstruation comes from the Latin word for month, which in turn is related to the word for moon. The average length of a human menstrual cycle is close to the length of a lunar cycle, though it varies from person to person and is not exactly the same. Some researchers believe this connection is meaningful, that human biology, like the biology of so many other creatures, was shaped in part by the rhythmic presence of the moon. Others are more cautious and point out that the similarity in timing may be coincidental. But what is clear is that the moon's influence on life is not limited to gravity and tides. It extends into the very rhythms of biological time, into the cycles of reproduction, of migration, of behavior. Life on Earth didn't just happen on a planet that happened to have a moon. Life on Earth evolved with the moon as a constant presence. Life and moon grew up together over 4 billion years, each shaping the other in ways both obvious and subtle. And the moon we have now, this particular moon, large and close and stabilizing, may be in part the product of the two-moon collision that happened before any of this began. The second moon gave its body to the first. The first moon became the moon we have, and the moon we have helped create the conditions for the life that eventually looked up and wondered where the moon came from. A circle, a long, slow 4 billion year circle. For a moment, just breathe. You are part of that circle. You always have been. A sleep reset. Let me pause here for just a moment. We are deep into the night now, deep into this story, and I want to take a breath with you. If you are still awake and listening, I'm glad you're here. But I want to gently remind you that you do not need to stay awake to be part of this. If sleep is close, if your thoughts are becoming soft and your awareness is becoming gentle and unfocused, let it come. Do not hold it back. Do not try to catch just one more part of the story before you let yourself go. The story will always be here, and sleep, real, deep, restful sleep, is more important tonight than any words I could say. So take a breath. Let your body be heavy. Let your thoughts dissolve like sugar in warm water. If you're lying down, feel the surface beneath you, the weight of your own body supported completely. You're not floating. You're not in danger. You're held, supported, safe. The world outside is doing what it always does. The Earth is turning. The moon is moving through its orbit. The stars are doing their quiet, slow work across billions of light years of space. You are allowed to be still in the middle of all of that. You are allowed to rest. Chapter 31. The Dinosaurs and the Moon. Let us move forward in time again. Past the Cambrian. Past the first fish and the first forests and the first creatures that crawled up onto the land. All the way to the age of the dinosaurs. Roughly 250 million years ago, following a mass extinction that wiped out the majority of species on Earth, a new group of animals began to rise. Slowly at first, then more abundantly, then in extraordinary variety. The dinosaurs. They're so embedded in our imagination, the dinosaurs. Even people who know very little about science know dinosaurs. We grow up with them. They fill our picture books and our museums and our films. There is something about them that captures the imagination completely. These enormous, strange, utterly real creatures that once walked the same ground we walk, that breathed the same air, that looked up at the same moon. Not quite the same moon, actually. The moon in the age of the dinosaurs was a little closer than it is today. Not dramatically closer. Not close enough to look obviously different to a dinosaur's eye, but measurably closer. The days were slightly shorter. The tides were slightly stronger. The dinosaurs existed for roughly 165 million years. To put that in perspective, the entire existence of our genus, Homo, spans only about 2 to 3 million years. The dinosaurs were around for more than 50 times as long as any human being has walked the Earth. For 165 million years, dinosaurs of every size and shape moved across the face of this planet. Small feathered things that may have been able to glide between trees. Enormous, slow-moving giants that left footprints we still find in ancient rock today. Hunters with sharp teeth and complex social behaviors. Peaceful grazers moving in herds across ancient plains. All of them, on every clear night, would have seen the moon above them. Did they respond to it? Almost certainly, some of them did. Just as animals today respond to the lunar cycle, the animals of the Mesozoic era almost certainly had behaviours connected to the patterns of moonlight and darkness. Predators hunting more effectively on bright moonlit nights, prey animals behaving more cautiously, migrations and breeding cycles attuned to the rhythms of the lunar month. The moon was part of their world, just as it is part of ours, and then, 66 million years ago, a rock fell from the sky. Not a small rock. An asteroid roughly 10 to 15 kilometers wide, moving at tremendous speed, struck the Earth in what is now the Yucatan Peninsula of Mexico. The impact was catastrophic beyond imagination. The immediate area was obliterated, but the effects spread outward. Enormous fires, a massive cloud of debris thrown into the upper atmosphere, blocking the sunlight for months or perhaps years. The collapse of photosynthesis, the collapse of food chains. A long, cold, dark period that scientists call an impact winter, and at the end of it, the non-avian dinosaurs were gone, along with roughly 75% of all species on Earth. For a moment, just breathe. This is not a small thing to sit with. The end of the dinosaurs, the loss of such an extraordinary diversity of life. There is something genuinely sorrowful in it, if you let yourself feel it. But from that ending came a beginning. The small, furry, nocturnal mammals that had lived in the shadows of the dinosaurs for millions of years suddenly found themselves in a world with fewer large predators, with fewer competitors for resources, with empty ecological niches suddenly available, and they diversified, rapidly by geological standards, into an extraordinary range of forms, into the ancestors of every mammal alive today, including us. We exist because of that impact. Terrible and enormous as it was, it opened the space into which our lineage eventually grew. The world turns slowly, and the most devastating losses sometimes become the conditions for extraordinary new beginnings. Chapter 32. Coming toward home. We're moving into the later chapters of our story now. The information is becoming less dense. The pace is becoming slower, like a river that has been running swift and clear through mountain channels and is now widening, spreading out into the low country, becoming broad and slow and reflective. Let us take a moment to simply be in that widening. We have covered billions of years tonight. We have begun with fire and collision, with two moons circling a young and empty world. We have moved through the first oceans, the first life, the long patience of bacteria, the explosion of complex animals, the age of dinosaurs, the great catastrophe that ended that age. And we're now approaching the present, approaching the time of human beings, the time of people who looked up at the sky and saw only one moon and built entire worlds of meaning around it. But before we get there fully, I want to linger here for a moment, in the deep past. In the quiet span of time that is sometimes called the Cenozoic era, the age of mammals, the age after the dinosaurs, it is 66 million years of gradual, slow transformation, of mammals diversifying, of continents continuing their drift, of the climate shifting slowly, cooling toward the ice ages, of the Rocky Mountains rising, of the Amazon basin forming, of the first grasses spreading across wide plains and creating the conditions for the first grazing animals in their modern forms. 66 million years, and through all of it, the moon moving overhead every night, patient and silver and present, and then, in the last blink of all this time, something new appeared. Something that could look up, something that could wonder. For a moment, just breathe. Chapter 33. The first stargazers. The earliest members of our genus, Homo, appeared in Africa roughly 2 to 3 million years ago. They were not yet quite like us. Their brains were smaller, their tools were simpler. Their language, if they had anything we would recognize as language, was very limited. But they were curious. Curiosity is, in some ways, the most defining trait of our lineage. The willingness to look at something, even something that poses no immediate practical value, and simply wonder about it. Early humans looked up at the sky. We know this because of the marks they left behind. Cave paintings from tens of thousands of years ago include images that may represent the moon, the stars, patterns that could be early attempts at astronomical observation. Bones with notches carved into them, found at sites across Africa and Europe, some of them over 30,000 years old, may represent early lunar calendars, counts of the days between full moons, attempts to track the rhythm of the sky. These were people with no written language, no telescopes, no understanding of gravity or orbital mechanics. They did not know the moon was a rocky world. They did not know it was 238,000 miles away. They did not know it had formed from the debris of an ancient collision, or that it might once have had a companion. They just knew it was there, and that it moved, and that its movement could be counted and predicted. That is the beginning of astronomy, the beginning of science, in a way. The recognition that the universe follows patterns, and that those patterns can be learned. From those notched bones to the equations that describe the formation of the moon from the Theia impact is a journey of 30,000 years of human curiosity, passed from person to person, generation to generation, each one adding a little more to what we know. We are the inheritors of that entire journey. Every question you have ever had about the sky is connected to every question every human being has ever had about the sky. For a moment, just breathe. You're not alone in your wondering. You never were. Chapter 34. Reflection on smallness and belonging. I want to slow down here, in this later part of our story, and spend some time with something that I think is worth sitting with quietly: the feeling of smallness. We live in a culture that often treats smallness as a problem, as something to overcome. We're encouraged to be significant, to make our mark, to matter, and there is nothing wrong with wanting to contribute something meaningful to the world. But there's another way to experience smallness, a way that is not frightening or discouraging, but actually deeply restful. We are very small, not in a way that diminishes us, but in a way that releases us. The universe is approximately 13.8 billion years old. The Earth is 4.5 billion years old. Our species has existed for perhaps 300,000 years. Your own life is, in the scale of all of this, almost immeasurably brief. And that means that almost everything you are worried about tonight, everything that feels urgent and heavy and unresolved, is also very small in the scale of things, not unimportant. I'm not saying your concerns do not matter. They do matter. They matter to you and to the people around you, and in the context of your own life, they are real and significant. But in the vast, slow, patient time of the universe, they are small, and small things can be set down. Small things can be let go of, at least for a little while. The second moon that circled the Earth for tens of millions of years is gone, and the world continued. Life began. Creatures evolved. Civilizations rose. People fell in love and had children and built beautiful things and told stories to each other in the dark. The loss of the second moon was not the end of anything. It was just a change. Everything that has ever seemed like an ending has been eventually just a change. For a moment, just breathe. Let the weight of whatever you are carrying become just a little lighter tonight. You are small and you are held, and you are part of an enormous and ongoing story that does not depend on you to hold it together. The world turns slowly, and so do we. Chapter 35. The Moon as Teacher. In many ancient cultures, the moon was not just a deity or a symbol, it was a teacher, because the moon teaches the most fundamental lesson about time. It changes, not chaotically, not randomly, but in a perfectly predictable, perfectly cyclical way. New moon, waxing crescent. First quarter, waxing gibbous. Full moon, waning gibbous. Last quarter, waning crescent, and then dark again, and then the thin silver sliver of a new crescent, just visible at the horizon after sunset, beginning the cycle again. 29.5 days, month after month, year after year, century after century. The moon taught human beings that things end and begin again, that the dark part of the cycle is not permanent, that after the full brightness fades, it will return. That patience and observation reveal patterns that cannot be seen in a single moment. This is a lesson that applies far beyond astronomy. The grief you are carrying tonight will not always feel as heavy as it does right now. The uncertainty you're living through will eventually resolve into something. The tiredness in your body will lift after rest. The season you're in will turn. Nothing is permanent, and the moon, more than almost anything else in the natural world, has been showing us this truth for as long as we have been able to see. The moon waxes and wanes, the tide comes in and goes out, the earth turns and the sun rises and sets. Life breathes in and breathes out, sleeps and wakes. You breathe in and you breathe out, in and out. Chapter 36. The Moon at its Distance. There is one more thing I want to say about the moon before we begin to move toward our closing. We said earlier that the moon is slowly moving away from the Earth, growing more distant year by year, centimetre by centimetre. In the far future, billions of years from now, the moon will be far enough away that total solar eclipses, those beautiful moments when the moon exactly covers the sun, will no longer be possible. We are living in a window of perhaps hundreds of millions of years when the moon is at exactly the right distance to produce total solar eclipses. When it appears, from our perspective on Earth, almost exactly the same size as the sun, the moon is 400 times smaller than the sun, and 400 times closer to us. This creates an almost perfect visual match. No other moon in the solar system creates this kind of total eclipse for the planet it orbits. No other moon in the solar system is, by this coincidence of size and distance, exactly the right apparent size to cover its star's disk completely. We are lucky in a very specific and measurable way, and we are lucky in a temporary way. Someday, the moon will be too far away for this. The alignment will be lost. Total solar eclipses will give way to annular eclipses, where the moon is slightly too small to cover the sun completely, leaving a ring of sunlight around its edge. Beautiful in their own way, but different. And someday, far further in the future, the sun itself will change. It will expand slowly into a red giant, growing enormous and consuming the inner planets. The Earth, if it still exists, will be unrecognizable, but that is billions of years away. For now, tonight, the moon is in its window, at its perfect distance, casting its patient light across a sleeping world. For a moment, just breathe. We're in the right place at the right time. All of us, every living thing on Earth, existing in this window of cosmic coincidence where everything is arranged just so. That is worth noticing. That is worth feeling, even in the tiredness of a late night, even in whatever heaviness or worry or restlessness you carried to bed with you tonight. Underneath all of that, beneath all the noise of daily life, there is this: a moon at the right distance, a world at the right temperature, an atmosphere that lets you breathe, a night long enough to rest in. It is enough. It has always been enough, and now it is time to rest. Part 5 is the last part of our story. It will be slower still, softer, more like the last few pages of a book you've been reading by lamplight, your eyes growing heavier with each paragraph, the story becoming less something you follow and more something you simply float in. We will close gently. We will let the story dissolve, slowly, into something that is not quite words anymore, into the feeling beneath the words, the quiet, the warmth, the simple, extraordinary fact of being alive on a night like this one. But before we get there, just rest here for a moment. The world turns slowly, and so do we. The moon is there, outside the window, or behind the clouds, or shining on another part of the world while you sleep in the dark. It is there. It has always been there. And it will be there when you wake. Good night.